Logarithmic differentiation is one of my favorite topics in differential calculus. So the point is we are trying to take natural log on both sides to bring the exponent down before we differentiate the function. So when do we use logarithmic differentiation? Take a look at the example. I have four functions for you. So in the second function, looks like you have to use the power rule to bring the 1/2 down, and then using the chain rule to take the derivative of the radicand. And then after you apply the chain rule, you find out that there is a quotient rule. So in the first problem, you have x and then x squared plus 1 raised to some power, right? So it looks like you have to use the power rule first, bring the exponent down, and then take the exponent minus 1, and then after that you have to apply the chain rule. But sometimes inside the chain rule you might encounter a product rule or a quotient rule, so which is a lot of work. So we don't want to do that much work. So that is the first case. And then the second case is you have a function like in part C, you have a cosine x raised to an x power. All right, so the base has an x, the exponent has an x. I didn't give you a I haven't give you a derivative to let you know how to take the derivative of this type of function. So in all these cases, we have to use logarithmic differentiation. Let's start with something easy. So let's say we have e to the a equals to e to the b. So that means a must be equals to b, right? So if you take ln on both sides, and then ln e to the b, you bring the power down. So a times ln e equals to a times ln b times ln e, and then the ln e is equals to 1, so you have a equals to b. That is how we take natural log on both sides. So let's take a look at the first problem. So the first problem, we have a y is equals to x to the 3 over 4, and then square root x squared plus 1 divided by 3x plus 2 raised to the 5th. Okay, I want to take ln on both sides before applying any rule. So I'm going to take ln on the left and then ln on the right. So this tells me taking ln on both sides works. Okay, back to the problem. So this one we have ln y equals to, what's the first rules? Do you see what I type over there? ln a divided by b equals to ln a minus ln b. So you have ln the top minus ln the bottom. Do you see that the exponent is sticking out? So before we take the exponent down, this is 1 times another function. So we have ln x to the 3 over 4 times ln the square root of x squared plus 1. Actually, it's a plus. And then minus ln 3x plus 2. And then raised to the 5th. The entire expression is equals to ln y. And then I can bring the exponent down. So ln y is equals to 3 over 4 ln x plus, you bring the 1/2 down, and then ln x squared plus 1. This x squared plus 1 cannot be simplified. Minus 5 times ln 3x plus 2. That's it. There is no more simplification right here. And then you take the derivative on both sides. So this one is a y, and then on the other side is x. Then on the right hand side, you have to use the implicit differentiation. So to make this more clear, let me cut this and then bring it over here. So that affects the y too. Let's do that again. I'm going to do this as careful as possible. All right. I'm going to bring it over. Actually, you know what? Let's just do it right here. I am going to take both sides, take the derivative on both sides with respect to x, so which is d dx, and then d dx of the other side. So since the left hand side is y, we have to use implicit differentiation. So the derivative of ln y, we treat that as an x, right? So we have 1 divided by y, and then what? And then dy dx. Okay. And then the other side, so this one is 3 over 4 times 1 divided by x, and then plus 1 half. This is x squared plus 1. You bring that to the denominator immediately, and then using chain rule, you take the derivative of x squared plus 1, which is equals to 2x. So this is by a chain rule. And then minus, you bring the 3x to the denominator. This is a 5, right? And then the derivative of 3x, it's not a 3x, right? It's a 3x plus 2. 3x plus 2. So this will be a 3x plus 2. The derivative of that is equals to 3. So this 3 is from a chain rule. And then you have dy dx. So this is a 3 over 4x equals to, and then plus the 2 got cancelled, x divided by x squared plus 1, and then minus 15 divided by 3x plus 2. How do we handle the y? Just move the y to the right hand side. So we have the whole thing multiplied by y. So dy dx is equals to that, but we are not done. I don't want to leave the y in there. What is y equals to? Y is just equals to the given problem right here. So what we are going to do next is we are going to replace the y with the given problem, which is x to the 3 over 4 square root of x squared plus 1 divided by 3x plus 2 raised to the 5th, and then multiply the whole thing inside the square bracket. So 3 divided by 4x plus x divided by x squared plus 1 minus 15 divided by 3x plus 2. So that is the final answer of the first problem. And then let's take a look at problem B. So problem B, we have y equals to, save some space to do the dd, to do the ln, x minus 1, and then divided by x to the 4 plus 1. All right, so first I will apply log ln on both sides, and then lny is just lny, right? And then this one I can bring the 1/2 down, and then I have ln x minus 1 divided by x to the 4 plus 1. I took ln on both sides. I haven't differentiated anything yet. So this is ln one minus the other. Then you have ln a divided by b, that equals to ln a minus ln b. All right. This is supposed to be in green, right? So I will stick with green. So ln y, that is equals to 1/2 ln x minus 1, and then plus, no, not plus, minus 1/2 ln x to the 4 plus 1. Because this we have if you put 1/2 right here, then you have 1/2 raised to the whole thing, right? Then you have ln a minus 1/2 ln b. You have to distribute the 1/2. All right, can we still simplify any further? The answer is no. ln1 minus another term, ln1 plus another term cannot be simplified. So that's all we can do. So now we have to take derivative on both sides. So this we have d dx, and then this we have a d dx, derivative on both sides with respect to x. So on the left hand side we have a ln y, so which is 1 over y times a dy dx, right? So this is using implicit. And then we have 1/2, the derivative is 1 divided by x minus 1. The derivative of the function inside the ln is just equals to 1. And then minus 1/2, and then this is a x to the 4 plus 1. The derivative of x to the 4 plus 1 is just 4x to the 3rd. All right, so now basically the derivative is finished. What we have to do next is we have to bring everything together. So first we multiply the y to the other side, then dy dx. Here is what you can do. I'm going to draw the right now, and then I bring everything together. 1 divided by 2x minus 2. If you don't want to distribute, that is fine. Minus 2x to the 4 plus 2, and then this is 4x to the 3rd. And then if you are using a pencil, just simply erase the y and then replace that with the problem. So which is the square root of x minus 1 divided by x to the 4th plus 1. So that is the answer of part B. So moving on to C. C, let's use red. So in part C, we have a y equals to cosine x. So the base has an x, the exponent has an x. This one we have to use logarithmic differentiation. First, we take ln on both sides. So ln y is equals to ln cosine x raised to the x, and then you can bring the x down, and then this is ln y, and then now we are ready to do the differentiation. So using implicit, the derivative of ln y is 1 over y, and then dy dx, this is implicit differentiation. We differentiate both sides with respect to x. If you have a y, you do it anyway, but you add a dy dx at the end. And then the right hand side is a chain rule, so you have fg prime plus gf prime, so that is x times the derivative of ln, so you bring the cosine to the denominator immediately, and then using chain rule, you take the derivative of cosine, which is equals to negative sign, and then plus function g, and then function f, the derivative of x is just equals to 1, so you have dy dx equals to, you bring the y over, I will erase that later, and then we clean that up. So this one is negative x times tangent x, and then plus ln cosine x. So this is no longer a y, we don't want a y on one side, I want to replace the y with the function, which is cosine x raised to the x. So that is the answer of part C. Alright, let's go to the last problem. So the last problem, let's use pink. D. We have y equals to tangent x raised to the x. Oh, no, actually it's raised to 1 divided by x. Okay, so first we take ln on both sides. Ln tangent x raised to 1 over x, and then I can bring the 1 over x down. So that is 1 divided by x, and then ln tangent x. Okay, what's next? Next, we differentiate, right? So using implicit on the left hand side, we have 1 divided by y, and then dy dx, that equals to, the right hand side is a, is what rule? The right hand side is a chain rule, right? And a product rule. So we have fg prime plus gf prime. So 1 over x, and then we immediately place the tangent in the denominator. Using chain rule, take the derivative of tangent, this tangent, the derivative of tangent is secant square x, and then plus g, the derivative of 1 over x is equals to x raised to a negative 1, right? So you bring the negative 1 down, and then x to the negative 1 minus 1, which is a negative 2. Alright, and then you do your dy dx. You are going to leave some space because you have to bring the y over. And then this is a secant square x divided by x times tangent x, and then plus, or actually is a minus, x to square, and then ln tangent x, and then outside of the square bracket, you bring the y over, right? But you are not going to do the y, you just copy the problem in that place. So 1 divided by x. So that's the answer of part D. So that will be all in this part. If you think my instruction is helpful, click the like, give me a subscribe, share my video out. I will see you all in the next lesson.